The established narrative of human migration into the Americas traces a path from Asia, across the Bering Land Bridge, and southward. For generations, this model, supported by genetic, linguistic, and archaeological evidence, has formed the bedrock of our understanding. Yet, a persistent and highly controversial alternative, known as the Solutrean Hypothesis, proposes a dramatically different origin. A transatlantic journey from Ice Age Europe, thousands of years before the accepted arrival of any other human group. This theory posits that Upper Paleolithic Solutrean people, renowned for their distinctive stone tool technology in southwestern Europe, navigated the North Atlantic ice edge around 20,000 to 15,000 years ago, eventually settling the eastern seaboard of North America. At the heart of the Solutrean Hypothesis lies a singular, compelling observation. The striking resemblance between Solutrean stone tools from Europe, particularly their laurel leaf and stemmed bifaces, and the iconic Clovis points found across North America. Proponents argue that the sophistication and unique flaking techniques required to produce these tools are so specific that their independent invention on two separate continents, separated by an ocean, is statistically improbable. They suggest that this technological similarity is irrefutable evidence of a direct cultural link, a shared ancestry of napping traditions. This visual congruence, often presented as the primary pillar of the theory, has captivated audiences and fueled a contentious debate within archaeology. However, the allure of a dramatic narrative can often obscure fundamental principles of scientific inquiry. The mere appearance of similarity, while intriguing, is not in itself proof of direct connection or shared lineage. This foundational assumption that visual likeness must equate to cultural transmission represents a critical logical fallacy at the core of the Solutrean argument. It overlooks alternative explanations and dismisses the complex interplay of human ingenuity, environmental pressures, and the universal constraints of material science. To critically evaluate the Solutrean hypothesis, we must move beyond superficial resemblances and delve into the underlying mechanisms that can produce similar outcomes in disparate contexts. The scientific method demands a rigorous examination of all plausible scenarios, not merely the most sensational. What if the similarities in tool design are not the smoking gun of a transatlantic migration, but rather the predictable result of independent innovation driven by similar needs and materials? What if the human hand, constrained by the physics of flint knapping and the functional requirements of a hunting projectile, can only arrive at a finite number of optimal solutions? This documentary will serve as a skeptic's guide, dissecting the logical fallacies underpinning the Solutrean hypothesis. We will explore how the principles of convergent evolution, where unrelated species develop similar traits due to similar environmental pressures, can manifest in human technology. We will contrast this with genuine cultural transmission, where ideas and techniques are demonstrably passed from one group to another. By applying these robust analytical frameworks, we aim to demonstrate that the 3,000-mile journey proposed by the Solutrean hypothesis is not merely unproven, but actively undermined by a more nuanced understanding of archaeological evidence and the very nature of human innovation. Our focus will remain on the weaknesses of the hypothesis, not to dismiss the ingenuity of ancient peoples, but to uphold the rigorous standards of historical and archaeological interpretation. The concept of convergent evolution offers a powerful lens through which to examine the apparent similarities between disparate technologies. In the biological realm, this phenomenon is well documented. Distantly related species independently develop similar traits or organs because they adapt to similar environmental pressures or ecological niches. The classic example is the wing. Bats, birds, and extinct pterosaurs all developed wings for flight. Yet their evolutionary paths diverged millions of years ago, and the underlying anatomical structures of their wings are fundamentally different despite their shared function. The selective pressure of aerial locomotion drove the independent evolution of a highly efficient aerodynamic surface. Applying this principle to human technology, particularly stone tools, reveals a similar dynamic. When faced with the universal challenges of survival, hunting, processing food, shelter construction, and limited by the available raw materials and the physics of their manipulation, human ingenuity can independently arrive at remarkably similar solutions. Consider the properties of cryptocrystalline silicates like chert or flint. Their conchoidal fracture patterns, allowing for predictable flake removal, make them ideal for creating sharp edges. The goal of a projectile point, whether for a spear or an arrow, is consistent across cultures and continents: to penetrate, to inflict damage, and to remain attached to the shaft. These immutable physical laws and functional requirements act as powerful selective pressures on tool design. For instance, the development of the atlatl, or spear thrower, emerged independently in various parts of the world, including Pleistocene Europe, pre-Columbian Americas, and Aboriginal Australia. While the specific designs and decorative elements varied, the fundamental mechanical principle, extending the lever arm to increase projectile velocity, was discovered multiple times. Similarly, the concept of a barbed harpoon point designed to secure prey appears in diverse archaeological records from different continents and epochs, long before any plausible direct cultural contact. These are not instances of cultural transmission, but rather of convergent innovation, driven by a common problem and a finite set of effective solutions constrained by material science and human biomechanics. When examining projectile points, the engineering constraints are particularly acute. To be effective, a point must be aerodynamic to fly true, thin enough to penetrate deeply, and strong enough to withstand impact without shattering. It also needs a mechanism for hafting, attaching it securely to a shaft. These requirements naturally push nappers towards certain forms: a pointed distal end, a biconvex or lenticular cross-section for thinning, and a basal configuration suitable for lashing. Whether a point is stemmed, fluted, or simply tapered, these are variations on a theme dictated by the physics of impact and attachment. The striking resemblance between Solutrean laurel leaf points and Clovis points, particularly their bifacial thinning and often lanceolate shape, can therefore be viewed through this lens of technological convergence. Both cultures were producing highly efficient, large projectile points for hunting large game, using similar raw materials and facing similar physical challenges. To assume that their visual similarity must imply direct cultural contact is to overlook the powerful role of independent invention, driven by universal principles of physics and utility. It is a logical leap that discounts the creative capacity of human cultures to solve similar problems in similar ways, even when geographically isolated. In stark contrast to convergent evolution, cultural transmission describes the process by which ideas, technologies, knowledge, and practices are learned and shared directly between individuals or groups. This can occur through direct contact, observation, teaching, or even indirect diffusion over time and distance. When cultural transmission is at play, we expect to see not just superficial similarities, but a suite of shared, often idiosyncratic characteristics that are unlikely to arise independently. These traits often include specific manufacturing sequences, non-essential decorative elements, or patterns of use that are arbitrary rather than functionally dictated. Consider the spread of agriculture. While the independent invention of farming occurred in several primary centers globally, the subsequent diffusion of specific crops, farming techniques, and associated toolkits across continents is a clear example of cultural transmission. The spread of wheat and barley cultivation, from the Fertile Crescent, for instance, involved the transmission of specific plant varieties, harvesting methods, and processing tools, often accompanied by genetic evidence in human populations. This is not convergence. It is the direct transfer of a complex adaptive system. When archaeologists identify cultural transmission, they look for more than just a passing resemblance in a single artifact type. They seek a constellation of evidence, shared production methods that are more complex than strictly necessary for function, common stylistic choices that have no obvious utilitarian purpose, and often a clear chronological and geographical progression of the trait.
Look at the twist on this
For instance, if Solutrean peoples had indeed migrated to North America, one would expect to find not only Clovis-like points, but also other distinct Solutrean technologies and cultural markers. This might include specific bone and antler tools, unique artistic motifs, specialized hunting techniques, or even architectural patterns. The critical flaw in the Solutrean hypothesis, when viewed through the lens of cultural transmission, is this lack of a broader cultural package. While the Clovis point is undeniably sophisticated, its specific manufacturing sequence and morphology, including the distinctive flute removed from its base, is largely unique to North America. Solutrean points, while bifacially thinned and often lanceolate, lack this characteristic fluting. Furthermore, the wider array of Solutrean tools, their specific types of scrapers, burins, and bone needles, not to mention their cave art and personal adornments, are conspicuously absent from the early North American archaeological record. The presence of just one type of similar tool, amidst a sea of otherwise disparate technologies and cultural practices, significantly weakens the argument for direct cultural transmission. If a population truly migrated, they would carry their entire cultural repertoire with them, or at least a significant and identifiable portion of it. The argument for Solutrean-Clovis connection relies almost exclusively on the visual similarity of projectile points, isolating this one element from its broader cultural context. This selective focus ignores the vast differences in the surrounding archaeological assemblages, which show a clear continuity with an Asian origin for early North American populations. The absence of a comprehensive Solutrean cultural footprint in the Americas, beyond the debated tool typology, suggests that the perceived similarities are far more likely to be a product of independent innovation or convergent evolution, rather than a direct 3,000-mile cultural transmission across the Atlantic. The burden of proof for such an extraordinary claim demands a much richer and more consistent body of evidence. The Solutrean hypothesis, while intriguing, falls prey to several logical fallacies that undermine its scientific validity. One of the most prominent is the argument from silence, where the absence of evidence is interpreted as evidence of absence. Or conversely, the absence of contradictory evidence is taken as proof. Proponents often highlight the lack of definitively older archaeological sites in North America that clearly predate Clovis and show an unambiguous Beringian connection, using this perceived void to suggest a Solutrean entry. However, the absence of readily identifiable older sites does not negate the established genetic and linguistic evidence for an Asian origin, nor does it automatically validate an alternative theory that itself lacks positive supporting evidence. The archaeological record is inherently incomplete, and gaps in our knowledge are not licenses for speculative leaps, especially when overwhelming evidence points in another direction. Another critical fallacy at play is the hasty generalization or anecdotal evidence. The entire hypothesis hinges on the visual similarity of a specific type of stone tool. the Solutrean laurel leaf point and the Clovis point. From this single, albeit striking resemblance, a vast and complex transatlantic migration scenario is extrapolated. This is akin to observing that both a modern skyscraper and an ancient Roman aqueduct use arches, and then concluding they must have been designed by the same culture or that one directly influenced the other, ignoring millennia of independent architectural development and the distinct engineering principles at play. The similarities in tool form are treated as irrefutable proof rather than as a single data point requiring contextualization within a much broader archaeological and scientific framework. Furthermore, the Solutrean hypothesis often employs a form of confirmation bias, where evidence that supports the theory is emphasized, while contradictory or alternative explanations are downplayed or ignored. The vast genetic evidence linking Native Americans to Asian populations, the linguistic diversity patterns consistent with a long-term presence and diversification from a Beringian entry, and the overwhelming archaeological evidence of a continuous peopling of the Americas from the West are all significant challenges to the Solutrean model. Yet, these are often dismissed or inadequately addressed in favor of focusing on the tool similarities. A robust scientific hypothesis must not only explain its own supporting data, but also account for or reconcile with all available, relevant data, especially that which appears contradictory. Finally, there is an element of special pleading in some Solutrean arguments, where unique or extraordinary conditions are invoked to explain away difficulties. For instance, the lack of other Solutrean artifacts in North America is sometimes explained by arguing that the migrants were a small, specialized group who only brought their core tool-making knowledge, or that their other artifacts simply haven't been found or preserved. While these possibilities are not inherently impossible, they are invoked specifically to protect the hypothesis from disconfirmation, rather than being derived from independent evidence. Such explanations weaken the overall argument, as they rely on a series of convenient but unproven assumptions to maintain the theory's coherence in the face of significant evidentiary gaps. The strength of a scientific theory lies in its parsimony and its ability to explain phenomena with the fewest unproven assumptions, not in its capacity to construct elaborate explanations for missing data. Beyond the logical fallacies and the compelling arguments for convergent evolution, the Solutrean hypothesis faces significant challenges from established scientific disciplines, particularly genetics and linguistics. The cumulative weight of evidence from these fields overwhelmingly supports the conventional Beringian migration model, creating a formidable barrier for any alternative theory to overcome. Genetic studies, specifically those examining mitochondrial DNA, mtDNA, and Y chromosome DNA, have consistently demonstrated a clear and unambiguous link between Native American populations and ancestral groups in Northeast Asia. The vast majority of indigenous populations in the Americas carry specific haplogroups, A, B, C, D, and X, that trace their origins back to Asia, with a clear chronological progression consistent with migration across the Bering Land Bridge. While haplogroup X has sometimes been invoked by Solutrean proponents due to its presence in both Europe and the Americas, its specific subclades found in the Americas, X2A, are genetically distinct from European variants, X2B, X2C, etc., and show a clear ancestral link to Asian populations. The genetic divergence times calculated for these American haplogroups align perfectly with a late Pleistocene entry from Beringia, not a significantly earlier transatlantic journey from Europe. If a substantial Solutrean migration had occurred, leaving a lasting genetic imprint, one would expect to find a discernible genetic signature of European ancestry among early Native American populations that predates or is distinct from later colonial admixture. Such a signature has simply not materialized in the extensive genetic research conducted over the past decades. The genetic landscape of the Americas tells a story of Asian ancestry, followed by diversification and spread within the continents, with no significant pre-Columbian European genetic input. The absence of this expected genetic evidence is not merely a gap in the data. It is a powerful refutation of the Solutrean claim of a direct population transfer. Similarly, linguistics evidence provides another layer of disconfirmation. The incredible diversity of indigenous languages in the Americas is testament to a deep time depth of human presence and subsequent linguistic diversification. Linguists have identified broad language families and superfamilies that show clear relationships to Asian language groups, further reinforcing the Beringian model. The patterns of linguistic distribution and divergence are complex but generally consistent, with a relatively rapid initial peopling from the northwest, followed by thousands of years of independent development and geographic spread. A Solutrean migration would imply a separate linguistic origin, or at the very least, a significant linguistic influence that would be detectable. However, there is no linguistic evidence whatsoever to suggest a connection between any indigenous American language family and any European language family, particularly the Paleolithic languages that might have been spoken by Solutrean peoples. The vast differences in grammar, vocabulary, and phonology make any direct linkage highly improbable. The argument that such an ancient linguistic connection would be impossible to detect due to deep time is a form of special pleading. While reconstructing ancient languages is challenging, the complete absence of any plausible link, especially when compared to the demonstrable links to Asian languages, remains a significant obstacle for the Solutrean hypothesis. The combined weight of genetic and linguistic data presents a consistent and compelling narrative that stands in direct opposition to the claims of a 3,000-mile transatlantic journey. The enduring appeal of the Solutrean hypothesis, despite its significant scientific shortcomings, highlights a broader issue in archaeological interpretation: the human tendency to seek dramatic, singular explanations for complex phenomena, sometimes at the expense of more nuanced, evidence-based understanding. The idea of intrepid Ice Age Europeans crossing an icy Atlantic resonates with a certain romanticism, offering a compelling narrative that challenges established paradigms. However, the scientific method demands more than compelling narrative. It requires rigorous evidence, testable hypotheses, and a willingness to abandon theories when data contradicts them. One of the theory's most significant shortcomings is its reliance on a limited data set and a selective interpretation of evidence. As we have explored, the visual similarity between a specific type of projectile point is the cornerstone. Yet this similarity is easily explained by convergent evolution. The absence of a broader Solutrean cultural package in the Americas, including other diagnostic tool types, artistic expressions, or burial practices, is a critical missing link that proponents often struggle to address convincingly. If a population truly migrated, they would carry a more comprehensive suite of cultural traits, not just a single, isolated technological innovation. Furthermore, the environmental and logistical challenges of such a transatlantic migration are often underestimated or glossed over. While Ice Age Europeans were undoubtedly skilled maritime hunters, navigating the unpredictable and often treacherous North Atlantic ice edge for thousands of miles, while sustaining a viable population, presents an extraordinary hurdle. The logistics of carrying sufficient supplies, maintaining warmth, and navigating without advanced instrumentation over such vast distances would have been monumental, even for highly adapted Ice Age mariners. While not impossible, the sheer scale of the undertaking, coupled with the lack of direct archaeological evidence for such a journey, e.g. European-style boats or specific maritime camps along the route, adds another layer of implausibility. The theory requires a series of unsupported assumptions about ancient seafaring capabilities and survival strategies. The Solutrean Hypothesis also inadvertently distracts from the rich and complex story of the actual peopling of the Americas. The established narrative, supported by decades of interdisciplinary research, points to a series of migrations from Beringia, involving diverse groups who adapted to varied environments and developed distinct cultures. This complex process, driven by environmental shifts, technological innovation, and cultural diversification, is far more scientifically robust and culturally significant than a single, dramatic transatlantic crossing. By focusing on the flaws of the Solutrean model, we reinforce the importance of rigorous archaeological methodology and the dangers of allowing superficial resemblances to overshadow comprehensive scientific inquiry. The ongoing discovery of pre-Clovis sites with distinct lithic technologies in the Americas, often showing clear affinities to Asian tool traditions, further underscores the complexity and depth of the Beringian migration model, making a Solutrean origin increasingly improbable. In conclusion, the Solutrean Hypothesis, which proposes a transatlantic migration from Ice Age Europe to the Americas, stands as a compelling example of how intriguing ideas can falter under rigorous scientific scrutiny. While the initial observation of striking similarities between Solutrean and Clovis projectile points provided a visually arresting premise, a critical analysis reveals that this core argument is built upon logical fallacies and is overwhelmingly contradicted by a comprehensive body of interdisciplinary evidence. We have demonstrated how the principle of convergent evolution offers a far more parsimonious and scientifically robust explanation for the observed tool similarities. Faced with similar environmental pressures, raw materials, and the universal physics of flint knapping, independent human cultures can and do arrive at functionally similar technological solutions. The wing of a bat and the wing of a bird illustrate this biological principle perfectly. And the independent invention of the atlatl, or barbed harpoon, in diverse cultures provides ample anthropological parallels. To interpret tool similarity as automatic proof of cultural transmission is to ignore the creative capacity of independent human innovation. Conversely, the absence of a broader Solutrean cultural package in the Americas, beyond the debated projectile points, critically undermines the argument for direct cultural transmission. If a population truly migrated across 3,000 miles of ocean, they would carry a more comprehensive suite of their technological, artistic, and social practices. The lack of diagnostic Solutrean bone tools, art, or other artifacts in early American archaeological contexts stands in stark contrast to the expected outcome of a genuine population movement. Furthermore, the Solutrean hypothesis is directly challenged by the overwhelming consensus from genetic and linguistic studies. Genetic evidence unequivocally links Native American populations to ancestral groups in Northeast Asia, with no detectable pre-Columbian European genetic signature. Similarly, the deep time depth and diversification of indigenous American languages show clear affinities with Asian linguistic groups, with no plausible connection to European Paleolithic languages. These independent lines of evidence provide a consistent and coherent narrative of human migration that firmly supports the Beringian model and refutes a transatlantic Solutrean origin. The 3,000-mile mistake, therefore, lies not in the journey itself, which remains unproven and highly improbable, but in the logical leaps and selective interpretation of evidence that have sustained the Solutrean hypothesis. It serves as a potent reminder for modern viewers and aspiring historians alike. Extraordinary claims require extraordinary evidence. A single visually compelling similarity cannot override the cumulative weight of genetic, linguistic, and archaeological data, nor can it circumvent the fundamental principles of independent innovation. Our understanding of the peopling of the Americas is a testament to the power of interdisciplinary science, built on rigorous analysis rather than romantic conjecture.